Okay, so this is more practice problems for you to review for tomorrow's test. So here is the first question. It's going to be a radical. So 3 minus the square root of 2 squared. So this is a binomial squared. So what we need to do is write it 2 times and FOIL it. So I'm going to do it nice and slow so you guys can be working ahead of me. First, outside, inside, and last. I'm now going to combine my like terms so I can add 9 plus 2 and get 11. And then the 2 middle ones gives me negative 6 square root 2. And you're done. Yes?
You can only add square roots when they're the same, right? Like on the inside numbers.
Correct.
And when you add them, you add the outside.
Yes.
But you keep the inside number the same.
You keep the inside number the same and just add or subtract outsides.
And for multiplying, you always multiply the inside and outside.
Right, so you would do outside with outside, inside with inside.
Even if the numbers are different.
Yes, you can multiply different numbers. But adding, you can only add radicals when they're the same. The radical. Okay, let's try another one. More square roots here. So the next one, we are going to have to rationalize this by multiplying by the conjugate. So I have 3 plus the square root of 2 divided by 1 minus the square root of 3. Remember, to get rid of that square root of 3 in the denominator, I need to multiply by its conjugate. Now, the common mistake, or people are just going to multiply it by root 3, but again, we're multiplying it by 1 plus square root 3. Exact same numbers, but I changed the sign. Yes. So now we're going to turn this into 2 FOIL problems. Now, shortcut for the denominator, if you don't want to have to go through the whole FOIL process, when we FOIL the bottom, the outer and the inner are going to cancel. So technically, all you need to do for that denominator is first and last. But I'm going to do the whole problem just to show you that the outside and the inside, once I FOIL it, cancel. And you get 0 for that part. So let's go ahead and do the numerator first. So I'm going to do first, and I get 3. I do outside, and I get 3 square root 3. I'm going to do inside, and I get 1 square root 2. I'm just going to put square root 2. And then last, I can multiply different numbers under the radical, and I get the square root of 6. Now, generally, you would look at this, and most of the time, the outer and the inner would be able to be grouped. But because my 2 square roots are totally different, there's no like terms here. So my numerator is simplified. Now I just have to FOIL the denominator. So let's go ahead and do that. Again, I'll do first. And I get 1 times 1 is 1. Then I do outside. And I get plus 1 square root 3. Inside, minus 1 square root 3. And then last gives me minus 3. So again, notice the outside and the inside here are going to cancel. So when you multiply something by its conjugate, all you need to do is first and last, because this will cancel. So now my final answer here is going to be 3 plus 3 square root 3 plus 2, square root 2 plus square root 6 all over negative 2. And you're done. I'm going to simplify this fraction that has radicals in it. So for number 3, I'm giving you 7, the square root of 35, divided by the square root of 42. Remember, if I want to try to simplify this before I start to rationalize, I can simplify numbers that are under the square root together. What could I divide 35 and 42 both by?
7.
Beautiful. So I'm going to change this to a 5 and this to a 6. So now I have 7 square root 5 over square root 6. Remember, we can never ever leave a square root in the bottom of a fraction, so we need to rationalize. The way that we rationalize is to make the denominator a perfect square. And to do that, I multiply it by itself. But remember, we need whatever we do to the denominator, I have to do to the numerator. So I'm going to multiply both the top and the bottom by the square root of 6. So here I would get 5 times 6 is 30. And then square root of 6 times square root of 6. I don't even need to multiply it. I just know when I multiply a root by itself, the radical disappears. Technically, I get square root of 36. 36 is a perfect square, so I get a 6. I cannot simplify the 30 and the 6 because the 30 is in, the 6 is out. So I'm done. Yes?
If you didn't simplify from the beginning, would you still get the same answer?
Yes, but you would have had a really large radical to break down because you'd have to multiply 42 times 35, and then you would have had to simplify that huge radical. But you'd still get the same thing. You just have a lot more work. It's easier to simplify before you start. Okay, now we're going to add radicals. Again, remember when we're adding square roots, the number under the square root has to be exactly the same. So what I need to do when my square roots are really large is I need to simplify them first. Now, I'm not going to go all the way to prime. I'm going to look for the largest perfect square that's a factor. So for my 600 here, I'm going to factor this to 6 times 100. And then I can see that the square root of 100 is 10. 6 is not a perfect square. There aren't any other perfect squares hiding in there, so that 600 is now simplified. I'm going to do the same thing to the 54. I could break the 54 into 9 times 6. And then I can square root and get 3. Actually, let me do it here. 3 times the square root of 9 is 3. The square root of 6 I leave. And now I get 9 square root 6. Remember, when you add radicals, the radical stays, and you add the coefficients or the numbers outside. Okay, so this is a valid question. Let's say you didn't realize that 6 times 100 was 600, and you did 2 times 300, and then you had to keep going, and then 2 times 150, and keep going until you get to prime, and keep going, and keep going, and then 5 times 10, 2 times, or 5 times, let's see, 2 times 5, let me erase, I'm going too fast. The 5 just comes down as a 5, the 10 is the 2 and the 5. So now I've got all of these numbers in the bottom, so I'm going to make my pairs. Pair 2s, pair of 5s. So one of the 2s comes out, one of the 5s comes out, 5 times 2 is 10, the 3 and the 2 go back under, and the 6 stays underneath. So if you're not good at recognizing the largest perfect square that's a factor, you do the whole tree, and you make your pairs. Everybody good on that? I just took a shortcut. Next one, I'm going to multiply two binomials. Square root of 13 minus 2, square root of 13 plus 2. Again, two binomials, I'm multiplying them, I'm foiling. However, those of you who are really good and realize that these are conjugates, really all you have to do here is first and last. However, I will do the whole FOIL process for you. So the square root of 13 times the square root of 13 is 13. The square root of 13 times 2 is 2 square root 13. The square root of 13 times negative 2. And then negative 2 times positive 2 is negative 4. Notice, again, these were conjugates. This middle cancels out. I'm left with 13 minus 4, and my answer is 9. Pretty good? Let's try another one. Breaking down a radical. This one is 5 square root 63. Simplify this radical, and again, you would factor the 63. Again, I'm going to go jump right to 9 times 7. I know that the square root of 9 is 3. It comes out. 7's not perfect, stays behind. 15 root 7. So again, for those of you who need to do the whole tree, you would do 9 times 7, 3 times 3. And again, these are all still under radicals. Make your pair of 3s. A 3 comes out, but you already had a 5 outside, and then you multiply it, and you get the same answer either way. So if you're good at recognizing perfect squares, try to break it into the largest perfect square, and then just square root it. Otherwise, you can do the whole tree, and you can do prime numbers. Let's do another multiplication with radicals. So for number 7, square root of 5 times the square root of 500. Now, I could multiply this and get 2,500 and then have to break it down, but instead, I'm going to factor this thing. Now, because we're not using a calculator, multiplying this and then finding the square root of 2,500 might be a bit challenging. So sometimes it's easier if you factor your numbers before you multiply and start looking for pairs. So again, I'm going to break the 500 into 5 times 100. Again, if at this point you realize that 100 is a perfect square and you've made a pair of 5s, the pair of 5s, 1 comes out. The square root of 100 is 10, so it's out of the radical. So my answer here is 50. And again, if you didn't realize that, you would keep breaking the 100 down. 10 and 10. Again, if you see you have a pair of 10s, you could pull one of them out. So wherever you can realize that, hey, wait a minute, I got a perfect square here, let me take it out, you could stop. Otherwise, go all the way to prime and get your pairs. Number 8, adding and subtract. Final answer is 50. Because here, pair of 5s, pair of 10s, 1 comes out. Either way, I get 50. All right, adding and subtracting. 1 over x squared minus x minus 2 minus 1 over x squared minus 5x plus 6. Don't try to say that my common denominator is going to be both of these huge things. Factor them first. So the first one is going to factor into x minus 2 and x plus 1. The second one is x minus 2 and x minus 3. This actually is a hard trinomial because some people think maybe the factors of 6 are 1 and 6. But again, remember, that's a positive 6, so the signs need to be the same. So always, once you think you've got the factors, do a quick FOIL check and make sure that you pick the right numbers. So now, my common denominator needs to represent everything. So it's going to have an x minus 2, an x plus 1, and an x minus 3. I've already covered this one. So this is my common denominator. So let me write it 2 times because I'm going to show what happens to my numerator. Bless you. So now this one, the first fraction here, I'm going to look to see what it's missing, and it's missing the x minus 3. So whatever you're going to multiply to get to the denominator, you do to the top. Luckily, my numerator originally was just a 1, so I'm just going to write x minus 3, because 1 times anything is itself. The second fraction, you can see that it's missing the x plus 1. So put it up at the top. Now, here we go with the common mistake. See this nice handy dandy subtraction sign here? You need to remember to distribute it to the x and to the 1. Needs to go to both pieces. So now this would simplify to x minus 3, the same numerator the first one, minus x, and you know what? I wrote the wrong problem. Let me quick modify this problem. I'm going to make this an x. Make this top number an x. Sorry. So x times, so I'm going to actually distribute a negative x. So negative x squared minus x, just to make it a little more complicated. All right. So this x distributes, and I distributed the x as a negative x. I still have the same denominator.
So you can just make it plus negative x at top.
Plus negative x. Yes, you could. You could do a key flip change, yes. All right, so now I'm going to add my like terms. This and this cancel. So now I'm just left with negative 3 minus x squared over x minus 2, x plus 1, x minus 3. Now, some people are going to be tempted and think that you could cancel that x minus 3, but you cannot. The only way you could have canceled that is if you could have factored that numerator. I can't cancel anything. I'm done. Let's try some easier ones. Let's try some exponents. X to the negative 3, y to the 4th, over 5 raised to the negative 3 power. Remember, when you have a negative exponent, think reciprocal here. So I'm going to flip this fraction. I'm going to put the 5 in the top, the x to the negative 3, and the y to the 4th in the bottom, and then make the exponent positive. Remember, when it's a power to a power, I'm going to multiply those exponents. I could assume this has a little 1 here. So this would become 5 to the 3rd, x to the negative 9, y to the 12th. Now, another way I could have tackled this problem is I could have moved my negative exponent here to the top. Oops. And then multiply it. Either way. But let's go ahead and take care of this. So then I'm going to figure out what 5 to the 3rd power is. I'm going to now take care of this x to the negative 9 power. The instructions will say leave all answers with positive exponents, move it to the top, and leave the y to the 12th at the bottom. And you're done. Yes?
So we have to flip it before we distribute the exponent?
You could distribute it first. If you want to distribute the exponent first, just remember that, you know, you could distribute it as a negative 3 and then just adjust your negatives. So these negative exponents have different methods. You could distribute it first. You could flip it first, make it positive, move all the negative exponents, however you want to deal with it. But just know that in the final answer, all exponents need to be positive. Yes?
At the beginning, because you have just before you flipped it, put the x at the bottom.
Absolutely. Yep. All right, let's try another one. Nice and easy on this one. 27x to the negative 3. Write this with positive exponents. Keep in mind, the only thing that has the negative 3 on it is the x. The 27 stays in the top. The x to the negative 3 goes to the bottom. And you're done. Let's try a fraction exponent now. Negative 81 to the 1/4 power. Remember, when it's a fraction, the denominator is the root, the numerator is the exponent. So really this means negative 81. I want to find the 4th root of it and then raise that answer to the 1st power. Anybody remember what happens with this one when I try to take it? It's not possible. So you would either put no solution, can't do it, because we have not learned about imaginary numbers yet. For our purposes, we're only writing real answer numbers. So whenever the root is an even number and the base is negative, we can't do it. We can do it with an odd root, but not with an even root. Let's try an odd root. Let's say it was negative 27 to the negative 1/3 power. Again, negative exponents, think reciprocal. So I'm moving the negative 27 to the bottom, making the 1/3 positive, and now I'm going to find the cubed root of negative 27. This is possible when that root is an odd number, because I can find a number that I can multiply 3 times that gives me negative 27, and that's negative 3. Yes?
What if for the first example, the negative sign is outside of parentheses?
Then you could do it. Then you would just have a negative root as your answer. So let's say it was negative, let me see if I can do a different color. If it were like this, and that's a positive 81 in there, then we could do this, because the only thing that the 1/4 is on is the positive 81. So I could drop my negative sign, put the 81 in the radical, and then I could see that my answer is negative 3. So you can do it when it's outside the parentheses. Let's try another one. Let's do 81 to the negative 3/4 power. Again, negative exponent turns it to a fraction. The power becomes, the power becomes positive. And then we're going to find the 4th root of 81 and then cube that answer. So this becomes 1 over 3 to the 3rd, which is 1 over 27. So don't try to do too much at one time. If you have to write out step by step, do that. Let's try another one with a negative exponent.
Ms. Gordon?
Yes,
Because we can't have we're not having calculation, right?
correct. No calculator. Not for a while.
Okay. How would you recommend we study like all the different roots? Like I didn't know that the 4th root of 81 was 3. Like how would you recommend that?
The difference between this problem and this problem, so see how this one has an 81 as the negative sign as the base. This is the negative sign on the exponent. The negative sign on the exponent just makes it a fraction. But when the base is negative and this number right here is an even number, you can't do it. Let me show you one more example. I have 2/3 raised to the negative 4th power. Again, think reciprocal. 3 over 2. Make the exponent positive. And then you would do 3 to the 4th, which is 81. 2 to the 4th, which is 16. Yes? Okay, there's a few more problems we'll do with fraction exponents. So 27 to the negative 1/3 power. We're going to move the negative exponent. Again, think reciprocal. Move the 27 to the bottom of the fraction. Make the exponent positive. And now we're going to find the cubed root of 27, which is 1/3. Then we're also going to do one more. 32 to the negative 3/5 power. Again, it's a negative exponent. Let's make it a fraction. Make the exponent positive. And now we would find the 5th root of 32 and then cube that answer. So the 5th root of 32 is 2. We'll now find 2 to the 3rd power, and my answer is 1/8. Let's do one more with some negative exponents on variables. So if my original problem is 27 x to the fourth y to the negative 2 over negative 36 x to the negative 1 y to the negative 3. I'm going to move all of my negative exponents to opposite of where they are. So that will come down. And then lastly, the y to the negative 3 would go up. So let's rearrange the problem. So this would become 27. X to the fourth is positive. It stays where it is. The x to the first will come up. Then the 36 is down at the bottom. And then I'm going to move the y squared to the bottom. And then I'm going to move the y cubed to the top. Now I can go ahead, I could reduce my fractional part, the 27 over negative 36. I could divide both of those numbers by 9, and this would become 3/4, and the denominator stays negative. I'm going to go back. Because I'm multiplying these x's, I'm going to add their exponents. So this would become x to the fifth. And now for the y's, because I'm dividing them, I'm going to subtract their exponents. So 3 minus 2 gives me y to the first. So I'll go ahead and write my y up at the top because it's a positive exponent. And I'm done. I can move the negative sign to the front of the fraction and write it like that. Or you could leave it in the denominator. Let me do 2 more adding and subtracting problems just to practice that one more time. So if we have 2x over x minus 5 plus 5 over 5 minus x, if you realize that these two denominators are the same thing except for they're opposite, what I could do is multiply this one by negative 1. Once I distribute a negative 1, it's going to turn into negative 5 plus x, and then I could apply my commutative property and flip it around. Now remember, whatever you're going to do to the denominator, do to the numerator. So now this one's taken care of, but now my new numerator is negative 5 over x minus 5. This fraction is good. I didn't need to adjust it. And now I'm just going to go ahead and I can combine my like terms. And actually, let me change this to a subtraction sign. Now notice that the negative negative here is going to become positive. So the final answer here is going to become 2x plus 5 over x minus 5. I just wanted to demonstrate when you have a negative negative here, if you do a key flip change, it turns positive. One other example, 2 over x minus 3 plus 5x over 3x plus 4. Now, notice on this problem, I can't factor my denominators. So everything's fully factored. So now my denominator is going to consist of both of these. So it's going to be x minus 3 times 3x plus 4, and x minus 3 and 3x plus 4. So now I'm going to go back and look to see what each one is missing. So my first fraction, it needs the other denominator. So I'm going to multiply the top and the bottom by 3x plus 4. Now this 2 is going to distribute. So my new numerator here is going to become 6x plus 8. Over here, to the 5x, I'm multiplying the top and the bottom by the x minus 3. And again, this 5x is going to distribute to both. So it'll become 5x squared minus 15x. Now at this point, I can go ahead and just write all my numerator all on one line with the one single denominator, which is x minus 3 times 3x plus 4. I now need to go back and combine my like terms. So I have the 6x and the 15x, the negative. Those are the only things I can combine. I'm going to go ahead and write this in standard form just to make sure to see if possibly I could factor it. So I'm going to write the 5x squared first. Then I'm going to combine these two. This gives me negative 9x and then plus 8. Rewrite the denominator. Now what I need to double check is to see if I could factor this. So if I tried to multiply the beginning and the end, I was looking for factors of 40 that give me negative 9, and there aren't any factors. So this question is done. I can't factor or cancel anything else out. So this would be my simplified answer. So again, the test tomorrow will cover R5. Most specifically from R5, it's going to cover R5C and R5D. R5C was the adding and the subtracting fractions or rational expressions, and this was the complex fractions, which was section D. And then from R6, that was the exponent. And we did break that into 2 days. The first day were the negative exponents, and then the second day were the fraction exponents, or the rational exponents. Then R7, that was just 1 day, and that was square root. So be able to break them down, to simplify them, be able to add them, subtract them, multiply them, rationalize, everything we covered in R7. So the test tomorrow is 20 questions, and you're not using a calculator. So you have 2 videos now with review problems. You have the review that you did for homework, and then I recommend you go back through your notes and also go through your homework problems. That's it. Good luck tomorrow.